Today we will learn projectile motion related to JEE Mains and Advanced, and for the first part you can see it is also for NEET aspirant also, but this video as we move forward it will be for Mains and Advanced. So let's start. See, we know that motion under one dimensional motion, any motion is one dimensional only for three cases. If its initial velocity is 0, that means you have thrown something like this, whose initial velocity is 0. This is the case 1. Whose initial velocity of the projectile is in the direction of the constant acceleration. You thrown something in the downward direction, thrown, or you have thrown something in the upward direction. You have thrown something in the upward direction. That is also your motion under one dimension. This is the motion under one dimension. It may be parallel or anti-parallel also. So these three cases are the projectile motions, are the motions under one dimension. If these three cases doesn't happen, if you throw it with some angle, with some initial angle, then it will call as if it is not 0 degree or 180 degree, that means if it is not parallel or anti-parallel, that means the motion would be projectile motion. Now see, we know in the gravitational chapter we learn that as we move upward or as we move towards the center of the earth, the gravity will change. But here all other cases, in the projectile motion, we will assume that height is much less. So g is constant throughout, otherwise it is not possible to calculate projectile motion. There are different types of projectile motion, we will see. See, one can happen this theta, you have thrown something with angle theta with a initial velocity u. You have thrown something from a height in the horizontal direction with a velocity u, that may be a projectile motion. You have thrown something with angle with the horizontal, you have thrown something with angle with the horizontal, something like this. You have thrown something in the downward direction, you have thrown something in the downward direction with the angle, with the initial angle. If you have a slanting height, something like this, this may also be a projectile motion where this angle is alpha, this angle is beta, and you have thrown something from the slanting height towards the downward direction with alpha and beta, Let us say this angle is alpha, this angle is beta. So these are the types of projectile motion. For NEET aspirant, you have only this case, only two cases. For mains aspirant, you have these two cases, and for advanced aspirants you will have these two cases also. So we will move forward and learn all the projectile motion. Let us see, there are two methods to solve a projectile motion. Method 1 is projectile motion. See, we already know that projectile motion, these motions is with a constant acceleration. So we can use equation of motion, that is v equals to u plus at and s equals to ut plus half at square. Let us say we have thrown a object with the initial velocity u with the angle alpha with the horizontal, and acceleration due to gravity is always towards downward. Now see, what would be the horizontal component? Horizontal component would be u cos alpha, and what would be the perpendicular component or vertical component would be u sin alpha. So from this we can say that we have to break this u in rectangular components, that is in the cos component and sin component. So u can be represented as, what is x in the x axis, in the horizontal, this is horizontal direction, this is vertical direction. Horizontal direction or x axis, the unit direction vector is I cap, and in the y axis direction vector is j cap. So u can be represented as u cos alpha, that is, this is also known as ux, that is horizontal component, ux into I cap, plus this is also known as uy into j cap. And see acceleration. We already know these directions from our kinematics lectures, that right hand side is positive, left hand side is negative, upper side is positive and lower side is negative. So acceleration due to gravity is always towards downwards. So here it would be, the acceleration would be minus g into, and what is the direction? Direction is towards the negative y axis. So it would be minus j cap. So minus g j cap would be your acceleration A. Now if we want to find out the velocity at, let us say at time t, we want to find out the velocity of this projectile. So we have to apply v equals to u plus at. Now what is the v? V is u cos alpha I cap plus u sin alpha j cap, and what is a? A is our minus gj into t, minus gj into t. Now if we want to find out displacement at time t, so displacement, apply the formula s equals to ut plus half at square. So we know u, we know a, put the values, you will get the answer. Always remember, in projectile motion we mainly use these two formulas, v equals to u plus at and ut plus half at square, s equals to ut plus half at square. Most of the sums will be solved by these two formulas. Now let us see one question. A projectile is projected with a velocity of 50 meter per second, that is u is given as 50 meter per second, with an angle 37 degree with horizontal. Find velocity, displacement and coordinate of the particle after 2 seconds. So we have thrown this object with 50 meter per second, 37 degree with the horizontal, and this is I cap, this is j cap, this is I cap, this is j cap. So our horizontal component would be 50 cos 37 degree, and our vertical component would be 50 sin 37 degree. So we already know that cos 37 degree, cos 30 sin 37 degree, sin 37 degree, value of sin 37 degree is 4 by 3 by 5, and cos 37 degree is 4 by 5. This is 0.6 and this is 0.8. Remember these two values, I have already told you in kinematics. So put the values of cos 37 degree and put the values of sin 37 degree. So you can be represented 50 ux I cap plus uy j cap. Now after putting the values, you will get something like this, 40 I cap plus 30 j cap in meter per second. Now acceleration is in the negative y axis, so it would be minus 10 j cap. Now apply v equals to u plus at. So we know u, and we know at. U is, we have just calculated u, 40 I cap plus 30 j cap, plus acceleration is minus 10 j cap, and t is 2 seconds. This is given in the problem, t is 2 seconds. So after simplification you will get this. See, 30 j cap minus 20 j cap is 10 j cap. Now apply s equals to ut plus half at square. You know u, you know t, you know a, you know t. Put the values, after calculating, you will get 80 I cap plus 40 j cap. So this is the displacement vector, right? S is 80 I cap plus 40 j cap. This is the displacement vector. So from here we can say that Sx, that is in the horizontal direction, it moves 80 meter, and in the vertical motion it moves 40 meter. So this is our coordinate, x equals to 80 meter. This projectile has gone after 2 seconds in the 80 meter, and y is 40 meter. Let us see another problem. A particle is projected with velocity u at angle theta with horizontal. Find the time when velocity vector is perpendicular to initial velocity vector. This is a very extremely important type of problem. The concept is important, otherwise it's very simple. See, you have thrown an object with velocity u. They are asking find the velocity vector, find the velocity when it is perpendicular to initial velocity. So let us say this is the velocity. Let us say they are asking about this is the velocity v, extend this in the backward, and this is the u. So see, in this direction the line of application of u and the line of application of V, they are perpendicular. So this angle is 90 degree. So they are asking this V, where this V is perpendicular to initial velocity u. So here V is perpendicular to u. So we know from vector dot product that if two vectors are perpendicular, then their dot product would be 0. So V dot u should be 0. Now what is V here? Here we can write V as u plus at, because acceleration is uniform, and this is u equals to 0. Now see, what is u? U is, x component of u is u cos alpha, u cos theta, and vertical component is u sin theta. So u cos theta I cap plus u sin theta j cap. And what is acceleration here? Acceleration here is minus gj. So minus at, that is minus gj into t. Now what is u? Again same thing, u cos theta I cap plus u sin theta j cap. Now there is a dot product. Remember, there is a dot product. That means similar product would be 1. That is I dot 1, I dot I, j dot j, k dot k would be 1. So see, I dot I, that means u cos theta into u cos theta, that is u square cos square theta. I dot I is 1. Now see j, I dot, now see j, u sin theta into j cap plus u sin theta into j cap, that is u square sin square theta. Now there is another component of j, that is g, this thing. So j into this and j into this. So j square, j into j is 1. So minus gt into u sin theta, that means minus ug sin theta into t. That should be equals to 0 as it is. Now see, u square, take common u square, sin square theta plus cos square theta equals to 1. This is ug sin theta t. Now t would be, this is u, cancel one u from both the sides. So u by g sin theta, or you can say u cosec theta by g. There is another alternative method to solve this type of problem. See, if we assume that this is a u, initial velocity u, with from the horizontal direction the angle is theta, and this is the direction of acceleration towards downward. Here we have assumed that a is g. So if you rotate this, towards the x-axis, then you don't need this thing. You don't need this thing, minus gj. You don't need this thing. We have rotate. Just assume that this is positive x direction. Just assume that this is positive direction. So this would be as it is. You don't have to take this thing. So let us say this initial velocity is the angle between initial velocity and acceleration is alpha, let us say. So how can we represent alpha? Alpha is 90 plus theta. Alpha is 90 plus theta. So again same concept, because they ask you about u and v, where u and v would be perpendicular. So u and v should be, the dot product should be 0. Again same thing, u plus at dot u should be 0. Now see, how can we write u dot u? That means u square mod of u square, and u dot at, u dot at. Now what is our u? U is u cos alpha. U is u cos alpha. So u cos alpha, and acceleration is equal to g, because we have taken this as positive x-axis. So acceleration is g and t as it is. So u square plus ug. Now cos alpha, what is alpha? 90 plus theta. Cos 90 plus theta is minus sin theta. So take there, you will get the same result as we have got in this result. So remember these two methods. These methods are extended. So let us see our method 2 of solving projectile motion. In this method, see, this is very important. Please concentrate. Select two mutually perpendicular directions x and y. So see, in the normal projectile motion, in the normal plane, the horizontal plane, we already know that x-axis and y-axis is a perpendicular. So we choose in the horizontal direction as x cap, x I cap, and this is y j cap. But for a slanting height, for plane, for an inclined plane, what you have to do? You have to choose that same axis. That, see, this plane, x-axis, choose x-axis along the plane, inclined plane, and choose y-axis is perpendicular to the plane, not to the perpendicular to the horizontal, perpendicular to the plane. Choose y-axis and x-axis, something like this. Only then you can solve this type of problem. After that, apply proper components, that is x component, y component, all those things. So Vx equals to ux axt, Sx equals to uxt half axt square, Vx square equals to ux square plus 2ax Sx. This is along x-axis, and for y-axis use the y component. Now always remember, in projectile motion, if you want to calculate time, this equation is most of the cases is very helpful. S equals to ut plus half at square. Specifically apply this thing for calculation of time. Now in inclined plane, I have already told you how to solve, how to take axis. So see here, ux, this is ux, right? So u cos theta, and this is your y component. This is your y component, that is uy equals to u sin theta, perpendicular component, right? Concentrate on this thing. See here, angle is alpha. Here angle is alpha. That means if you throw something like this, see, if you throw something like this, the same angle alpha would be here. The same angle alpha would be here. Okay. So we can say that our x component is here now is u cos alpha, and our y component is here now is u sin alpha. Now what would be the component of acceleration? If you concentrate on this thing, see, mass always mg, weight always perpendicular to the horizontal. So that means here acceleration is perpendicular to the horizontal, and now this perpendicular. So if this angle is beta, this is 90, this is 90 minus beta, so it would be beta again. This will be beta. Now if this is beta, then what is the component of g? The component of g along this is g cos beta, right? And the perpendicular component along this is g sin beta. Now concentrate on this thing, that see, we have taken x-axis, positive axis towards right, but our g sin beta is towards left. So that means our acceleration component in the x-axis would be minus, because it is in the negative x direction. Now similarly, concentrate on this. The component of acceleration perpendicular to the plane is g cos beta. So see here, upward is positive y-axis, so downward would be negative y-axis. So our component of acceleration would be minus g cos beta. Remember this thing, this is extremely important. Choose the x-axis along the inclined plane and choose the y-axis along the perpendicular to the plane, and resolve the component of acceleration and velocity separately, and then apply equation of motion we have just shown here. So let us see another problem. A projectile is fired horizontally with velocity of 98 meter per second from the top of a hill, 490 meter high. Find the time taken by the projectile to reach the ground, the distance of the point where the particle hits the ground from the foot of the hill, the velocity with which the projectile hits the ground. So you have to calculate three things, that is the distance of the point where the particle hits the ground, this distance you have to find out. The distance of the point where the projectile hits the ground from the foot of the hill, that means you have to find this distance also. The velocity with which the projectile hits the ground, that means you have to find the velocity v here when it hits the ground. See, in this problem we have taken the direction in the right hand side as x-axis and in the downward as y-axis. So our acceleration would be plus g, right, because we have taken the downward direction as positive y-axis. You can take axis according to yourself, but apply with proper sign. The question would be very easy. Now we have taken here the right hand side as positive x-axis and downward side as positive y-axis. So according to our direction, see, we have thrown is in the horizontal direction of u 98 meter per second. That means our ux in the positive x-axis will be 98 meter per second, Here at this point there is no acceleration in the horizontal direction, so ax would be 0. Here we have thrown the object in horizontal direction, so there would not be any vertical component of velocity, and as we have taken the downward direction as positive y-axis, so our y component of acceleration would be plus g, because we have taken the downward direction as positive y-axis. So at point A, we can see that this height, this total height sy is our 490 meter. This sy height is our 490 meter. So sy would be, as we have taken the downward direction as positive y-axis, so our direction of distance from this point would be plus 490 meter. Okay, so we have to apply the component in y direction, that is sy equals to uyt plus half ayt square. Now we know sy, we know uy is 0, so half g as taken here as 9.8 into t square. After solving you will find t as 10 seconds. So we have found out the time when it reached from O to A. Now they are asking find the distance between B and A. Find the distance between, so that means in the horizontal direction. So in the horizontal direction x component would be sx. So apply sx equals to uxt plus half axt square. Now sx is BA. Now uxt, what is the ux? Ux is 98 meter, and what is the time? Time we have calculated out 10 seconds, and acceleration is 0. So this whole term would be 0 here. So BA comes up to be 980 meter. Now number 3, the velocity with which the projectile hits the ground. If you notice, if you observe this thing, that in this point at A point, we have two components, that is Vx and Vy. So our resultant of Vx and Vy would be the velocity at point A. So first of all find out Vx component. V equals to u plus at. Here ax is 0, so we have only 98 meter per second. Now apply Vy equals to uy plus ayt. Now uy is 0 plus ay is your g, and t we have calculated out 10 seconds. So this will also be 98 meter per second. We have assumed that this direction between the final resultant vector and this horizontal component is beta. So from this triangle, from this rectangle, we can apply the parallelogram law of addition to find out the v, which is root under of a square plus b square plus 2ab cos theta. As Vx and Vy component is at 90 degree, so our cos component will gone. So our resultant velocity would be root under of Vx square plus Vy square. So 98 square plus 98 square, you will get it as 98 root 2 meter per second. Now if you want to find the angle, so it would be, if this is Vy, then this will also be Vy. So Vy by Vx, 98 by 98, this is 1. So tan beta is 1, so beta should be 45 degree. Let's continue. See, if we have projected a particle u with an angle alpha with the horizontal axis, then we have to find some terminologies related to this projectile motion. The first one is your range r, that is this distance, and the time of flight, that is the object takes time to go from O to B, and the maximum height. Remember these formulas. The time of flight is your 2u sin alpha by g. The maximum height is your u square sin square alpha by 2g. Horizontal range r is u square sin 2 alpha by g. Now see, in order to maximize this range, this sin 2 alpha should be equals to 1. That means alpha should be 2 alpha should be 90 degree, alpha should be 45 degree. In order to maximize this range, the angle you should have projected the object is 45 degree. So here maximum range would be u square by g. Now see, if you have projected this object with u at 60 degree, and if you have projected this object u at 30 degree, then both of them will terminate into same point, that is the range would be same, for r 90 minus alpha and r alpha. that is if you have projected the object at 30 degree and if you have projected the object at 60 degree, then both of them will go in the same point. Now consider this formula of time of flight, maximum height and range would be same between lying on the same horizontal line. If 2 points, let us say this, if you have projected from a hill in the angle alpha with the horizontal, then if this point and this point are in the same horizontal line, then you can apply for this projectile motion the same formulas we have applied here. That is time of flight, that is OQM. OQM, that is the object takes time to go from O to M. OQM, same formula, that is PQ. PQ is the maximum height. Maximum height would be same, the formula would be same, and OM, that is range. Range would be same for same horizontal distance. Remember this is extremely important. For same horizontal distance, the formulas would be same as we have applied here. Now see, horizontal direction of a component of acceleration in the x horizontal is 0, that is horizontal component of velocity. What is the horizontal component of velocity? Horizontal component of velocity is u cos alpha. U cos alpha never changes. U cos alpha does not change during its motion. U cos alpha always same. U cos alpha always same. U cos alpha always same. Remember this is also an extremely important point. Now equation of, now see, motion in vertical direction is first retarded. Motion in vertical direction is first retarded, then accelerated in opposite direction. Then accelerated in opposite direction. Why? Because uy is upward, here uy is upward and acceleration due to gravity is downward, right? uy is upward and ay is downward. Hence vertical component of velocity first decreases from O to A, from this point to this point. The vertical component decreases because acceleration is in the downward direction, and then it increases from A to B. That means vertical component increases from A to B and decreases from O to A. The coordinates of velocity, the coordinate and velocity component are, see, s equals to x equals to, the coordinate is x and y, right? So x equals to, here we can say that is sx, that is horizontal distance, that is you can apply ux into t. Now what is ux? Ux is your u cos alpha, ux is u cos alpha into t. And what is y? Y is your sy, vertical distance of the object, sy. Now apply this formula, uyt plus half ayt square. Now what is uy? Uy is your u sin alpha, so u sin alpha t minus half gt square, y minus, because here acceleration is downward, so you have to take a equals to minus g. So that's why this is minus half gt square. Now we have already learned that velocity component never changes. That means initial velocity on the x direction and initial final velocity in the x direction would be same. That means if you projected this object from here to here, if they want to find out the velocity at here, at this point, then velocity would be same. That is final velocity and initial velocity component. Velocity component never changes. See, horizontal component of velocity does not change during its motion. So Vx and Ux would be same. Now if we apply Vy equals to Uy plus Ayt, you know Vy, you know Vy, Uy, what is Uy? That is u sin alpha and that is minus gt. Now here you have to apply the parallelogram law of addition in order to find out. This is your Vx, this is your Vy, that means this is your Vy. So you can see, apply parallelogram law of vector addition. These things are at 90 degree. So parallelogram, from parallelogram law you can say that V, that is V, the resultant velocity would be root under of Vx square plus Vy square, and tan theta would be Vy by Vx, Vy by Vx. Now equation of trajectory, remember these two equation of trajectory. Remember this two equation of trajectory, that is y equals to x tan alpha minus gx square by 2 u square cos square alpha. You can see here we have terms, x terms as quadratic. So that's why this motion, this projectile motion is parabolic, because x is in quadratic. You can write this thing as this thing, x tan alpha minus gx square by 2a square 1 plus tan square alpha, 1 by cos square alpha is sec square alpha, and sec square alpha is 1 plus tan square alpha. And in terms of range, sometimes they ask about in terms of range. So in terms of range, equation of projectile motion would be x into 1 minus x by r tan alpha. Remember this thing also, this is extremely important. So continuing with this lecture, projectile motion along up the plane. So you have projected in an inclined plane, this with alpha with the initial velocity u, and the inclined plane is at beta with the horizontal direction. Now if you see this location, in this location, that acceleration is downward, this is beta, so this thing will be 90 plus beta, so this would be 90 minus beta, so this would be beta. So our vertical perpendicular component would be, this is g, this is attached with beta, so this would be g cos beta, and this is g sin beta. Now take the axis I have shown in this. See, we have taken the axis, x axis, as along the plane. So this is our x axis now, and the y axis is perpendicular to the plane. This is our y axis now. So what would be the ux component? What would be ux? That means we need this component, this. What would be the ux? That would be alpha minus beta, alpha minus beta. So u, because we have thrown the object with u cos alpha minus beta. And what would be the acceleration along the plane? It is g sin beta, but it is negative in the negative x axis, so it would be minus g sin beta. Now what would be y, uy, that is this thing, uy, and this is ux. So what would be uy? U sin alpha minus beta. What would be ay? That means you need this thing, ay, that is g cos beta, and it is in the negative y axis, so it would be minus g cos beta. Now we have to find the time of flight. So see, at point B the vertical displacement is 0, right? At point B the vertical displacement is 0. So we can use sy equals to ut plus half ay t square, where sy is 0, and uy is our u sin alpha minus beta, and ay is our minus g cos beta. Put the values, take t common, and you will get the time of flight. You can take it as capital T also. So time of flight would be 2u sin alpha minus beta by g cos beta. Please remember this, and also the process, because in some problem we will not directly use the formula, we will go through the process. That's why I have shown the derivation. Now if you here put beta equals to 0, what do you mean by beta 0? Beta 0 means it is in the normal motion, right? It is normal motion, this motion, what we have learned earlier. So if beta equals to 0, then this thing, the time of flight, would be the same formula we have learned previously, 2u sin alpha by g. Now what is our range? For range, see, horizontal component of initial velocity. What is the horizontal component of initial velocity? Horizontal component of initial velocity, that is u cos alpha, this u cos, this is your u cos alpha, this is your u cos alpha. So horizontal velocity of initial velocity is u cos alpha. So that means we can say that OC equals to UH into t, velocity into time. Now we have just derived the time of flight, 2u sin alpha minus beta by g cos beta. Put the values here, you will get OC, that is horizontal range. Now see, we need this thing, right? We need this, because in this case our horizontal range is OB, but we have found out OC. Now cos beta, what would be cos beta from here? Base by hypotenuse, that is OC by OB, that is OC by OB. Now what is OB? OB would be OC by cos beta. So our horizontal range, which is this thing, would be OB equals to OC by cos beta. Now we have found out OC, put the values, you will get horizontal range as this thing. Now apply sin C minus sin D, that is this thing in this formula, this thing in this formula. We can write horizontal range in this term also. Remember this thing. Now if you have noticed here that the maximum horizontal range would be maximum when 2 alpha minus beta, this thing 2 alpha minus beta is pi by 2, that means alpha equals to pi by 4 plus beta by 2. Please remember this, pi by 4 plus beta by 2. If you put this here, you will get horizontal range, that is maximum range as this. And if you put beta 0 here, beta 0 means in the same motion, this is the same motion, beta 0. So you will get the maximum range, same maximum range we have derived earlier. So let us see for the down the plane what would be the equation. If you have thrown something from here, so it will go like this, and initial velocity is u here, and for horizontal direction the angle is alpha, and if this angle is beta, then this angle would also be beta, right? And if you see this direction, this is same as the previous slide we have learned, g, this is beta, if this is beta, then this angle will be beta, this is cos beta, this is sin beta. But the notable thing is we have taken here the direction in the left hand side as positive x axis and upper side as positive y axis. So according to our direction, see what is the angle of projection? Angle of projection is alpha plus beta here. So cos component would be horizontal component would be u cos alpha plus beta, and vertical component would be u sin alpha plus beta. And what would be ax here? Ax, that is along x axis, it would be g sin beta. In this case it is plus because we have taken the left hand side as positive x axis. Now what would be ay? Ay is in the downward, so it is minus g cos beta. Proceed as we have proceed in the earlier cases for up the plane motion. You will find that time of flight would be 2u sin alpha plus beta by g cos beta, and range as this thing, u square by g cos square beta sin 2 alpha plus beta plus sin of beta. If you have noticed one thing, in the for the up the plane, here it has minus sign, here it has minus sign, but we have here plus sign. So if you replace beta by minus beta, you will get the equation for down the plane. So it would be very easy to remember. If you have remembered the up the plane motion, you can remember the down the plane motion easily, because only replace beta by minus beta, you will get the equation for time of flight and range. Let us see one problem. A man standing on the hilltop projects a stone horizontally with speed v0. The picture is given, so v0 horizontally the velocity is v0 as shown. Taking the coordinate system as given in the figure, find the coordinate is 0 0, that means they have taken it is as origin. Find the coordinates of the point where the stone will hit the hill surface, something like this. So we have redrawn this picture. So they ask about to find out the range of this projectile, So see, this is same as this thing in the down the plane, it is in the down the plane motion. So for this we can use the range formula we have just learned, that is u square by g cos square beta sin 2 alpha plus beta plus sin beta. Here if you have noticed the horizontal direction, that is initial velocity u is v0, and here we have no alpha because we have projected this along the horizontal. So but here we have projected this with angle alpha, right? So here we do not have any alpha angle, so alpha is 0, and beta, as you can see, is theta. Beta, let us say this is beta and this is theta. So put all the values here in this equation, you will get the range as this thing. Now what is x? X would be, what is the horizontal component here? X is r cos theta, right? This is x equals to r cos theta. X is r cos theta. So x is r cos theta, you know the r, put the values, you will get something like this. What is y? Y is minus sin r sin theta. So put the values of r here and you will get the answer something like this. So it is very easy if you remember the formula and the techniques we have applied here in order to solve the questions very efficiently. So let us see another type of problem, relative motion between two projectiles. If you have thrown one object with velocity u1 with angle alpha 1, and if you have thrown another object u2 with angle alpha 2 with the horizontal, then you have to find the relative velocity between between 1 and 2 or 2 and 1. Okay. So see here, acceleration of both the particles is downward, right? We can see that acceleration is due to gravity and this is downward. So relative acceleration between them is 0. Why? We know that relative acceleration a12, that means we are finding out acceleration of 1 with respect to 2, that is a12 is a1 minus a2, both of them are g, so g minus g is 0. So we can see that if relative acceleration is 0, that means the motion is uniform. Relative acceleration is 0, that means the motion would be uniform. From here we can say that u1x is u1 cos alpha, u2x would be u2 cos alpha 2, u1y would be u1 sin alpha 1, and u2y would be u2 sin alpha 2. Now what would be u12x? What do you mean by u12x? u12x is relative velocity of 1 with respect to 2 in x-axis or in horizontal direction. So it would be u1x minus u2x. Put the values. What would be relative velocity in y direction? That is u12y is u1y minus u2y. That is this. u12x and u12y are the x and y component of relative velocity of 1 with respect to 2. Hence, relative motion of 1 with respect to 2 is a straight line at an angle theta. So, relative velocity of 1 with respect to 2 is a straight line with an angle theta with the horizontal. So, this would be our u12x and this would be our u12y, and we have just proved that u12, that is, it's a uniform motion. So, u12 is equals to 0. We have to find out this u12. Now, if u12x equals to 0, if this is equals to 0, if 12x equals to 0, that means this is our u12x, that means this is equals to 0, that means u1 cos alpha equals to u1 cos alpha 1 equals to u2 cos alpha 2. The relative motion is along y axis. If there is no horizontal component, then it would only have vertical component. So that is along y axis or in vertical direction, that is the projectile is upward. Similarly, if u12y equals to 0, that is if the relative velocity of vertical component is 0, relative velocity of vertical component is 0, if this is 0, that means this is 0, that means u1 sin alpha 1 equals to u2 sin alpha 2, that means there is no vertical component, that means the object is moving in the horizontal direction. Relative motion is along x-axis, that is in the horizontal direction, because there is no vertical component, that means theta is 0. Remember this is extremely important point. Relative acceleration between two projectiles is 0. We have just proved this. u12 is 0. Relative motion between them is uniform. Therefore, condition of collision of two particles in air is that velocity of one with respect to the other should be along line joining them. That is, two projectiles A and B in mid-air, then VAB should be along the line AB and VBA should be along the line BA. So remember these points. Now we will solve some specific problems in order to apply these formulas and concept. So let us see one problem related to relative velocity between the two projections. A particle A is projected with an initial velocity of 60 meter per second at an angle of 30 degree to the horizontal. At the same time, a second particle B is projected in opposite direction with initial speed 50 meter per second from a point at a distance of 100 meter from A. This distance is 100 meter. If the particles collide in air, they will collide in air. Find the angle of projection alpha of the particle B, this angle of projection. First question. The time when the collision takes place and the distance of P from A, distance of P from A where the collision occurs. That means, let us say this is the distance of P from A where the collision occurs. See here in the right hand direction we have taken x axis and this is y axis, and the relative velocity of A, particle A with respect to B is in the direction of, let us say, in this direction, because we have seen in the last slide that we have to find the collision will occur in the relative displacement in the straight line. See here, acceleration of A is in the g is always downward, right? G is always downward. So acceleration would be minus g into j, and acceleration of B particle will also be minus g into j. Now what would be uax? That means this component, that is angle velocity. U is 60, so 60 cos 30. Calculate, you will get 30 root 3. What would be uay? That means this uay, that is 60 sin 30. The angle is 30, so 30 meter per second. What is ubx? This is ubx, right? We have taken the right hand side as positive, so left hand side would be negative. So our ubx would be minus 50 cos alpha, and what would be by? By would be in the upward direction, which would be 50 sin alpha. See, relative acceleration between the two particles is 0, because both of them, see, minus gj. So relative acceleration is same. So from here we can say that the motion is uniform. The relative motion between the two particles is uniform. So we can assume, it can be assumed that B is at rest, and A is moving with a velocity uab. The same thing, because the motion is uniform. So that's why we have assumed that the particle B is at rest and the object A is moving in the direction of uab, not uab. That is in the relative direction between A and B. Hence, the two particles will collide if uab is along AB. This is possible only when the vertical component is 0. If you have taken the velocity along uab, that means the vertical component is 0. That means uay, this is uay, and this is uby should be same, and that is possible only when uay equals to uby. That is, component of relative velocity along y axis should be 0. So we can use this, that 30 equals to 50 sin alpha, 30 equals to 50 sin alpha, and or alpha equals to 30, this is 30 meter per second, uay equals to uby. What is uay? Uay we have calculated 30, and what is uby? Where is uby is 50 sin alpha. So from here calculate, sin alpha would be sin inverse 3 by 5, that is 37 degree. Now this is the first answer, the angle of the projection. So we have found out the angle of the projection as 37 degree, that is B. Now second question is time when the collision takes place. You have to find the time when the collision takes place. So let us find out the magnitude of the relative velocity uab, that is u mod of uab would be mod of uax minus ubx. Now what is uax? Uax is 30 root 3. What is ubx? Ubx is minus 50 cos alpha, so it will be plus 50 cos alpha. Now we have calculated out cos alpha, that is 37 degrees. So put the values, you will get 4 by 5. Cos 37 degrees 4 by 5. Calculate, you will get 30 root 3 plus 40 meter per second. So what would be the time? Time would be distance by velocity. We have calculated velocity, relative velocity. So distance is AB, given 100 meter, and we have calculated this thing. Put, you will get 1.09 second as the time of collision. Now second thing is distance of point P from A. Distance of point P from A. You have to calculate this distance where the collision occurs, when the collision takes place. So what would be the distance? The distance would be velocity multiplied by time of the particle A, and this distance would be ay t minus half g t square. Put all the values, we know all the values, you will get it as 62.64 meter. Let us see if you have problem calculating out this distance. See, you have to find the distance from the point A to this P. So this would be, let us say the velocity is at this position, velocity in the horizontal direction is uax, right? And vertical position, vertical velocity is uay. But we don't need velocity, we need distance. Distance is velocity multiplied by time. So what would be the distance along x-axis? It would be ux multiplied by time. And what would be the distance along y-axis? It would be distance s equals to ut plus half at square. Apply this formula. As acceleration is downwards, it would be minus half gt square. And what is your uy? This is sy. Now what is your uy? Uy is uay t. Uy, that's why we have used here uay t minus half gt square. Now say this is a vector component. This is, let us say this is dx. Let us say this is dy. So what would be the resultant? Resultant would be d. So what would be the d? D would be root under of dx square plus dy square. So dx is our this thing, dx is our this thing, and let us say dy is our this thing. uayt minus half gt square. Square root them, you will get the. Let us see two types of problem. We have already seen various types of problem. Now for the end of this lecture, we will see two types of problem. Let us see, based on the concept of horizontal component of the velocity remains unchanged, because we already know horizontal component always remains constant. A particle is projected from the ground with velocity 40 meter per second. This is projected at 60 degree angle from horizontal. Find the speed when velocity of the particle makes an angle 37 degree from horizontal. It is given that you have to find the speed when the velocity of the particle makes 37 degree. So it may happen in the two cases. Either in this case the velocity makes 37 degree with the horizontal, or in this case velocity makes 37 degree with the horizontal. So at time t1 and at time t2, both of them are at the same height. So they have made 37 degree each. So we have to find for t1 and t2 also. So here we can say that ux, what will be your ux? This is your ux. Ux will be 40 cos 60 degree. This is 40 meter per second, 20 meter per second. What would be your uy? This is your uy. Uy would be 40 sin 60 degree. Calculate, you will get 20 root 3. Now what is the acceleration? Horizontal acceleration direction, because we know here acceleration is only due to gravity. That means we have only the component of acceleration in the downward direction. So horizontal component is 0, and ay would be minus 10 meter per second because g is downward. So horizontal component, find the speed when you have to find the speed. So horizontal component, we know that horizontal component remains same. So that means Vx should be equals to Ux. What is Vx here? What is Vx here? Vx would be V cos 37 degree. So this V cos 37, that is Vx, should be equals to U, Ux. Now what is Ux? Ux is U cos 60 degree, 40 cos 60 degree. That is 40 cos 60 degree. So this component should be equals to this, because we know horizontal component remains same. So Vx equals to Ux. So V cos 37 degree equals to 20. So after calculation you will get, because cos 37 is 4 by 5, so you will get 0.8, and after calculation you will get V equals to 25 meter per second. Now coming forward to number 2, find the time for the above situation. You have to find this time. So you have two times, t1 and t2. You have to calculate both the time. So Vy, apply vertical motion. Vy equals to uy plus ayt. Now from this we can say that t equals to Vy minus uy by ay. Now let us calculate t1 first. So what would be t1? T1, what is Vy? Vy here, V sin 37 degree. So V sin 37 degree minus uy. What is uy? Uy is 20 root 3 divided by ay. What is ay? This is minus 10. So after calculating you will get 1.96 second. Now let us calculate t. Now in this scenario, the vertical component is towards the downward. That means ay here is your V sin 37 degree towards downward, right? So as it is downward, so sign would be negative. So Vy would be minus V sin 37 degree, and Uy is at as it is 20 root 3 divided by G. G is towards downward, so minus 10. After calculation you will get 4.96 second. Now the last is to find the vertical height and horizontal distance of the particle from the starting point in the above position. So you have to find the vertical height. See, in these two scenario, vertical height is same, h. So you have to find the h. So h equals to, we can say this as it is the vertical motion. So h equals to uy t1 plus half ay t1 square. We are calculating for t1. You can calculate for t2 also. So you know the component uy, you know t1, you know ay, that is minus g. You know t1. After calculation you will get 48.7 meter. Now what would be, you can take t2 also, answer would be same. What is the horizontal distance? That is x1 and x2. So what is the horizontal distance here? x1 is horizontal distance, that means you have to take the component of velocity of horizontal component, that is ux into t1. So 20, ux is 20, and what is t1? t1 is 1.96 second. So 20 into 1.96, we will get this. And what is the x2? x2 is ux2 into ux into t2. This is time t2. So ux into t2, put the values, you will get the answer as 99.2 meter. See, we will see another type of problem. It will be from our basic concept. At a height of 45 meter from ground, velocity of a projectile, see, a vector component is given. So from this we can say that our ux is 30 and uy is 40 meter per second. Find initial velocity, time of flight, maximum height, horizontal range of this projectile. Here it is vx and vy. From this you have to find the initial velocity, it's the final velocity. So let us say the object is at in this position where this is vx and this is your vy. And let us say the horizontal component, if initial velocity is ux and vertical component is uy. And this height is given in the question. This height is given in the question at a height of 45 meter. That means the particle is at 45 meter from horizontal. So from this we can say that vx is 30 and vy is 40 meter per second. So horizontal, we know from the basic concept that horizontal initial velocity never changes. So that means vx and ux are same, right? So that means 30 meter. So ux is 30 meter. First answer done. Now vertical component of velocity. See, vertical component of velocity. This is your initial velocity vertical component, and this is your final velocity vertical component. Remember this, vertical component of velocity is more at a lesser height. If this height is less, that means the vertical component would be more. But if it is at maximum height, vertical component 0, right? At maximum height we know the vertical component is 0. We have only horizontal component at maximum height. There is no vertical component. So that means we can say that at lesser heights vertical component would be more, because from going through O to A, let us say the vertical component decreases, and at the maximum position vertical component 0. That means that at a lesser height velocity is more, vertical component of velocity is more. That means uy is here, so obviously uy, vertical component of uy should be greater than vertical component of vy. Remember, this is extremely important point. Now see, what would be our uy? So v square is equal to e square plus 2as. So here a is minus g, so we can say that uy equals to root under of v square plus 2gh. Put all the values, you will get 50 meter per second. See, here it is ux, here it is vy, ux, here it is ux, here it is vy. So our final velocity would be u. So what would be u? U would be ux square plus uy square. So ux we know, uy we know. Put the values, you will get the answer. What would be tan theta? Tan theta would be uy by ux. Put the values, you will get the answer. Time of flight, we know all the formula, 2u sin theta by g. 2u sin theta, that is u sin theta. What is u sin theta? U sin theta is your uy. U sin theta is your uy. So put the values of uy, that is 50, you will get the answer. What is horizontal range? What is maximum height? Maximum height is u square sin square theta by 2g. So u sin theta whole square. U sin theta is again uy. So uy square by 2g, put the values here, you will get the answer. Now horizontal range is horizontal range, that means we have to take the horizontal velocity ux into time of flight from going to this to this, time of flight and this to this, time of flight. So time of flight is 10 and ux is 30, so answer is 300 meter. I hope you are finding this video interesting and helpful, so please support us. We will upload previous year questions from projectile motion. Let us target at least 100 likes for this. Thank you.